Well, hello viewers, welcome back to Builder Science. In today's video, we're going to be talking about electrolysis calculation. Okay, so now this video is the part 3 of a video series. You can look that up on our channel. Well, without wasting much time, let's get straight to business. So now, these calculations we're going to be doing will be divided into basically two parts. That's two case study or scenarios, whereby we are going to be calculating the ones that are related to what now? The Faraday's first law of electrolysis, and doing some calculations on the questions that are related to what now? Faraday's second law of electrolysis. But with that being said, these two cases we have here now, these two questions we have here now, they are from the first law of what? Electrolysis. So now, for us to calculate, for us to handle any question under what calculations involving electrolysis, you can use what this simple formula here. You say that what now? Q, which is quantity of electricity, equals what? FCN. Q equals what? FCN. Where Q here stands for what? Now the quantity of electricity I've explained before in our previous video. Where Q stands for what? The quantity of electricity that is passed through the electrolyte. Then F here is what? Standing for the what? Now Faraday's what? Constant. Okay? Faraday's constant. The C here is what? The charge of the what? Ion that is being the charge of the ion that is being what? Deposited, which is usually what? Ionic charge. The charge of the what? And then N stands for the what? The numbers of moles of the what? Substance being deposited at a given what? Electrode. So if you are new to any of these terms, you can look at the part 1 of this series, so that you will get exactly what I'm trying to say. Okay. So now in this case, now of course we already know that basically we already know the relationship between the numbers of moles and other parameters like mass over molar mass, volume over what? Gaseous molar volume. Let's just keep that in mind where we're calculating here. So with that being said, this formula now from what? Electrostatics, or should I say current electricity in physics? Quantity of electricity is calculated by multiplying what? Its current by its time. So now this formula can also be written as what now? I times T, which is current times time, equals what? FCN. So now let's apply this formula in order to what? Calculate what? These two questions. Okay? So now with that being said, let's go straight. So now here we have what? 0.1 Faraday of electrolysis, 0.1 Faradays of electricity was passed through a solution of copper 2 sulfate. The maximum weight of copper deposited on the cathode would be, we're looking for the word, the maximum weight, which is what? The mass of the copper that will be deposited. Remember, when we say cathode, by this time you should already know what cathode is all about. What we mean by cathode at this point. If you don't understand, check out the part 1 and part 2 of this video series. Okay? So now from here now, what we're going to be looking at now, it says 0.1 Faraday was passed through the 0.1 Faraday of electricity was passed through the solution, that is the electrolyte. So now, in this situation now, the quantity of electricity in this case was not given to us in coulombs. You know, quantity of electricity by measure is what? In coulombs. I've said it before in the previous video. But in this case, it wasn't given to us in coulombs. It was given to us in what? Farad. I also told you the relationship between that coulombs and what? Faraday's constant. Okay? So now, let's compare this Faraday now, this quantity of electricity in Faraday to coulombs of what? Now, electricity. So now, from what we said in the last video, we said well, 1 coulomb of electricity. Okay? Rather, we said 1 Faraday of electricity, rather. We said that 1 Faraday of electricity in coulombs is equivalent to what now? 96,500 watt coulombs. That's the relationship. So now in this case now, we have 0.1 Farad. So now, if 1 Faraday is equivalent to what? It's equivalent to what? 96,500 coulombs. Then what will now be 0.1 Farad? Okay? Let's put it as what now? Unknown. So that if you should do something like this, simple proportion. Remember our simple proportion for mathematics, that's the knowledge we're using here. So that if you do that now, we now have x, that will be what now? Multiplied by, x now equals to what? 0.1 multiplied by what now? 96,500 watt coulombs. Okay? So that if you should do this math correctly, that's 0.1 multiplied by what now? 96,500. This will be equivalent to what now? This at this particular point, we call it what? X here, which is representing the what? The quantity of electricity in what? Coulombs. So now equals to what? 90. That's 9,650 coulombs. Okay? Okay? I'll say now. From this case, now we're supposed to be converted our what? Farad to what? Our Farad to what? Our Farad to what? Coulombs. We're supposed to be converted our quantity of electricity in Farad to coulombs. Okay, so now we have gotten our Q. From this simple operation, we have gotten our what now? Q. Our Q is equals to what now? 9,650 coulombs. So now let's look at, remember we're trying to solve with that formula. Let's bring that to what? The F there. The F in this case now, we have to fall back to the what? Ionic what? That's electrolytic what? Half reaction. So now by this time, if you don't know what electrolytic half reaction is about, you can look at our previous video. From this now, we already know that copper is deposited in the cathode. So now since copper is deposited in the cathode, it therefore means that what now? Copper, it therefore means that copper 2, in this case it's copper 2, this is the solution, it's always in its what? Is in what? Ionic form. So now, copper plus 2 will now have to undergo what? Copper will now have to undergo what? Reduction. Since copper is undergoing reduction in electrolysis, that's metals undergoing reduction, so now it's going to receive what? Two electrons. So now give us what? Our solid what? Copper. Okay? So now from this half reaction, now we can tell that what? From this half reaction, we can tell that what? From this half reaction, now we can tell that when copper 2 ion receives what? 2 electrons, it forms our what now? Copper solid. Okay? Our solid copper. From this now, we have 2E here. That means this C now, which is standing for what now? Ionic charge. Our C will not be equals to what now? Our C will not be equals to what? 2 electrons. Okay, that's 2E minus. Okay, remaining the numbers of moles. So now these numbers of moles, of course, they said our copper here is what? It has a molar mass of what now? 64. So now let's look for it. Since we are looking for the mass, so let's not worry. Let's look for the numbers of moles first. So these numbers of moles first is what? Unknown. So let's look for these numbers of moles using this formula. Then we can find the what? Mass that was missing. So now with that being said, let's just continue from here. So now Q equals what? FCN. Okay? So now what's our quantity of electricity? That's 9,650 equal to Faraday's constant. Faraday's constant, 1 Faraday, we only have 1 Faraday. Faraday's constant is equal to what? 96,500 coulombs. In this case, that's what it means. Okay? Faraday's 96,500 coulombs. Since electrons here, we have 2 of it. It will not be what? Multiplied by 2. Okay? Times what? Our n. We didn't put the E there, just show that it's what? 2 moles. Okay? So now 2 electrons. Okay? This is receiving 2 electrons. That's our C will not be what? Electrons. So now let's look for this n. Our n will not be equals to what? 96. That look at it now. We have what? 96. That's what? 9,650 divided by what now? 96,500 multiplied by 2. Okay? 96,500 divided by multiplied by 2. Now if you do this correctly, we have what? 9,650 divided multiplied by what? Then divided by what? I think it should give me what? Around 193,000 if I'm not mistaken. That's 96,500 multiplied by 2. Should give me around 193,000. So now if you should do this mathematics now, we now have our mole now equals to what? 9650 divided by what now? 193,000, which will eventually give me 0.05 moles. Mind you, this is not our final answer, okay? So now we just got the mole there. We now know that what now? From this mole that we have here, we can now go back to our normal what? Of course, our very popular what? Concept of mole. We say that what now? Numbers of moles is equal to what now? Reacting mass over what? Molar mass. From this, you can get the mass here. From this case, since we already have the mole and we have the molar mass, which is 64, you can now say N equals from this formula now. N equals mass over molar mass, right? If not beautiful, then we now have what? Our numbers of moles will now be equals to. We're not going to come here and say what? Our numbers of moles is what? 0.05 equals to our mass is unknown, right? Mass over our molar mass here is what? 64. Okay, coming back, we're going to continue from here. We're going this way. So now, mass over molar mass. Now, our mass therefore will now be equals to this times this. Okay, when you multiply, that's 64. Let me come here. Our mass therefore will now be equals to what? 0.05 multiplied by what now? 64. Okay, when you multiply that, you have what? End up having what now? 3.2 grams. Okay, we now have 3.2 grams as a what? Our final answer. That's our mass. Okay, using this formula. At the end of the day, we now have what? That should be option D, option E rather. So our correct option here is what now? Option E. Alright, so let's look at the what? Second question. The second question here says that what now? 0.1 Faraday of electricity deposited 2.95 grams of nickel during electrolysis of an aqueous solution. Calculate the numbers of moles of nickel that will be deposited by 0.4 grams, 0.4 farad. Molar mass of nickel was 58.7. Alright, from this case now, from the way we're looking at it now, we have two words, points of electricity in farad. So definitely we're not going to make use of this formula in this case. But rather we're going to be using what is an even simpler way of something, which is a simple proportion that we know. A simple proportion. So now from this now, from the question, 0.1 farad deposited what? 2.95 grams of what? Nickel. So now, another reason we're not able to use this formula because nickel now is a transition metal and they didn't give the what? They didn't put the compound with it combining with so that we can get the what now? The charge. So now the charge was not mentioned. Okay? The charge was not mentioned, so we're not able to use that formula. So now look at that. Now say calculate the numbers of moles. So now this 0.1 give me grams. Okay, no problem. Let me compare it with what mass. So I can find by the time I find the mass, I'll be able to use this formula to find the what moles. So now from this question, 0.1 gave us this. Then now 0.4 farad will now give us what? In grams. In grams. Mind you, I'm not looking for my answer in grams. My answer will be in moles. But by the time I get their mass, I'll be able to use this formula to convert it back to what? Moles. Okay? So now, from this now, since I don't know about the since 1 Faraday gave us this, then 0.4 will now give us what? So now by the time we look at this now, that goes 0.1 times x. You have 0.1x now equals to what? 0.4 multiplied by what? 2.95 grams. Okay? 2.95 grams. So now looking at that now, making x out of formula, x now equals to what? 0.4 multiplied by 2.95 divided by 0.1. Okay? So let's look at our x now equals to what? These are x in grams. Mind you, x in grams. So now if you do the math, if you should do the math correctly, we have 0.4 multiplied by what? 2.95 divided by 0.1. At the end of the day, we now have what? 11.8 grams. Okay? This answer here is in what? Mass. Okay? We've got now what are equivalent in what? Mass. Grams. Okay? But this is not our answer. These are mass. Now we now have to convert it to what? Moles in order for us to get it. For us to get the actual answer, we have to convert the mass to what? Moles using numbers of moles equals mass over molar mass. So now from this formula, numbers of moles equals to what? Mass over what? Molar mass. You can solve from here. Okay? Now numbers of moles is unknown. We want to provide them. No, now mole will not be equals to what? What's our mass in this case? 11.8 grams. So now 11.8 grams. That's 11.8 grams divided by what's our molar mass in this case? 58.7. So now we have 58.7 what? Gram per mole. So now at the end of the day, by the time we do that, we have about we have about 0.20 what? Mole. Okay? So now do we have an option there? Yes, option A is actually what? The correct answer. Okay? So now this goes for what now? This is actually the answer to what now? This number 2 situation. Okay? So now that means let's move to the what? Next question. Okay? Looking at this other question, this question says what? In an experiment, copper 2 sulfate solution was what? Electrolyzed, of course, electrolysis, using copper electrode. Okay? The mass of copper deposited by the passage of 16,000 coulombs of electricity is. So now from this question, we are asked to find the mass. We are asked to find the what? Mass. We are looking for mass. Mass is unknown. Mass is unknown. Then, of course, our quantity of electricity in coulombs. Of course, Q in our formula, you can make use of this formula as well because we know the charge of copper as well. Q equals to what now? 16,000 coulombs. So now, of course, F, we already know that F is constant, 96,500 coulombs. Then what else do we need? We need numbers of moles. Numbers of moles is also unknown. So now, by the time we get our numbers of moles from the question, from the calculation using that formula, we'll be able to convert it to what? Mass. Okay? So now, since we're looking for mass, this number will need it. So now, but as usual, we also need what charge. So now, for us to get the charge, let's write the electrolytic what half reaction for what copper. Like as usual, it's going to undergo reduction. That's copper 2 plus. At the end of the day, it's going to receive 2 electrons to give us our what now? Our copper solid. So now that means we are having what our charge here, which is electron, is what 2. Okay, our charge in this case is what equals to what 2. So now from this now, we can use this formula Q equals FCN. Okay, so let's go. Our charge of electricity, let's substitute. This will be 16,000 equals to what's our Faraday's constant? 96,500. In this case, multiplied by our charge, we have 2 of it times what? Remember, I'm going to put in 2 here, I didn't put E. So don't put your E as well. So now, by the time we do that, we have something like 16,000 will now be equals to this multiplied by this. I think we should have about 193,000. 193,000 N. Okay? So now making N solve the formula, we have N now be equals to what? 16,000 divided by what now? 193,000. Okay? So by the time we do that math correctly, we now have 16 divided by what now? We have 16 divided by 193, and we end up having what? 0.08290. Let's use this formula. These are numbers of moles. Okay? These are numbers of moles. That is moles. So these are value for our moles. But remind you, they said what? The mass of copper, not the mole of copper. This is the mole of copper. Okay? We have to find the mass of copper. So let's convert these moles to mass using what? This formula. Numbers of moles equals to what? Mass over what? Molar mass. Okay? So that you do that, N will now be equals to what now? So now we want to make mass sort of formula. Mass will now be equals to mass will now be equals to what? Mass will now be equals to what? Numbers of moles times or molar mass. And numbers of moles in this case is what? 0.08290 multiplied by of course our molar mass. In this case our molar mass is what now? 63. So our molar mass is what? 63.5. Okay? So now by the time we do that math correctly, we end up having 5.26 grams of what now? Copper. Okay? Of what now? Solid copper. So now it's as simple as that, okay? So now one more question before we call it what? A day concerning what? Calculations involving what? Faraday's first law of what? Electrolysis. Looking at this question we have here now, it says what quantity of electricity will liberate 0.125 moles of oxygen molecule during the electrolysis of dilute sodium chloride solution? Okay, so now from this case, now we're looking for the quantity of electricity. What quantity of electricity? Of course, in this case, like I told you, like we're going to be using the formula Q equals FCN. Okay, Q equals FCN. But before we start looking at formulas, let's bring out the words. Let's write the ionic word. Sorry, electrolytic word half reaction. So now, oxygen molecule. This is quite different, but this is a non-metal. Oxygen, it will be what now? Undergoing what? Oxidation, and it will move towards the anode. Okay, so now it's kind of different. So now, oxygen in this case, now oxygen molecule, this oxygen molecule. In this case, that's what we're going to be forming at the what? At the anode, depositing at the what? Anode specifically. So now in this case, we're going to have what? In this case now, we're going to have something like this. For the electrolytic half reaction, we're going to be having something like this. 2 O minus. That's 2 moles of oxygen ion. 2 moles of oxygen ion. In a molecule of oxygen, you have 2 moles of what now? Oxygen ion. So now 2 moles of oxygen ion will not be undergoing what? Oxidation. Okay? Will not be undergoing oxidation. In this case, it will be what? Losing electron to the what? Anode. So now I've explained it before now in the previous part in this video series. So now you should go understand that properly. You can go look at it. So now in this case, I'm going to be what? Undergoing what? Oxidation. We're going to be losing electron. By the time you lose that electron, place it on this side. So now total electron that it's going to be losing, because we have 2 moles of it ion here, it's going to be losing a total of what now? 4 electrons. Okay? To now form the what? Oxygen molecule we're talking about now, which is in the gaseous form. Okay? So now it will now have to undergo what? Oxidation. That's loss of electron then actually the anode to give us what? The oxygen we are looking for. But now we have simply written the words now. Electrolytic what? Half reaction. Since we have written the electrolytic half reaction in this case, but I'm going to ask myself from this case now, we can draw out what our parameter from the entire situation. Q is unknown, right? Q is unknown. So let's bring out our parameters. Q is what we're looking for. We don't know. Which is quantity of electricity. We don't know. Then F, which is our Faraday's constant. Of course, we know that it's what? 96,500 coulombs as usual. Then for our charge, which is C, C is equals to what? 4, because in this case now we have 4 electrons, losing 4 electrons. So now it's going to be what? 4. There's no to put the E there. You can say 4E minus, but when calculating, we're not going to be what? Put our E there, okay? So now what else do we need in the formula? We need the numbers of moles of what now? Oxygen. So in that case, there will be no much difficulty, okay? So now for oxygen molecule, let's quickly recall. For oxygen molecule, for a molecule of oxygen weighs 32 gram. That's the molar mass of what? One molecule of oxygen is what? 32 gram per mole. Okay, let's not forget that. So now, with that being said, we can find the most. So we're looking for the quantity of electricity. We're looking for the quantity of electricity we are looking for the quantity of electricity that will liberate 0.125 moles of what? Oxygen. The question now, N was given to us as well. That's the numbers of moles. The numbers of moles from the question is what? 0.125 moles. Okay? The numbers of moles was given to us. So now we have what? Most of the parameters. So we are looking for Q. So now substituting it into this formula now. Still on the calculation. Substituting it into it. So now our Q is unknown. Q equals what? F is what? 96,500 multiplied by what? Our charge. Our charge in this case is what? 4. So now it's going to be what? Look at it. 4 here. So now multiplied by 4, then multiplied by what now? Our numbers of moles, which is 0.125, which I got from the question here. So it's going to be what? 0.125. So now doing that math correctly now, doing that math properly, we have what? 96,500 multiplied by 4 multiplied by what now? 0.125 volts. So now our quantity of electricity, so it's very straightforward and quick. Our quantity of electricity is equal to what? 48,250 coulombs. Okay? Coulombs. So now if we look at it properly now, coulombs, if we look at it properly now, where is our answer falling to? That's option B. Our option B here is actually what's correct. Okay? So now, if you are having problem with the electrolytic half reaction, look at the part 1 of this series, okay? You understand it properly. Look at the part 1 of this series, you understand it perfectly, okay? So now just look at the part 1 of this series so that you can understand how to write the electrolytic half reactions for both metals undergoing reduction in the cathode and non-metals undergoing oxidation on the anode, okay? And the anode. So now with that being said, this will take us to the this will be the last question rather. The last question under the first case I'm talking about, that's involving Faraday's first law of electrolysis.